Mark your own. Number 1. At the cafeteria at PMSS, Chef Dueck has created 4 feature meals, 3 drink choices, and 4 dessert choices. So on your test on Wednesday, your test is Wednesday. I'm doing a tutorial today after school, by the way. Right. On your test, Ryan, it's going to follow roughly the same order that I taught you, which means you can almost certainly expect that number 1 is going to be fundamental counting principle. 1, 2, 4 choices, 3 choices, 4 choices, B. Except on your test, Holly, a friend of mine made up this test and he uses it with his kids. I won't do the none of the above, some of the above. The answer will always be there somewhere, okay? Number 2, how many different arrangements can be made using all the letters of the word Toronto, Ontario? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Factorial. Oh, but there's some repetitions. Also, just remember, the word arrangements, that's a synonym for permutation. Order matters. Anyways, 1, 2, 3 T's, 5 O's, 2 R's, 2 N's, is that right? Is it 3 factorial, 5 factorial, 2 factorial, 2 factorial, or am I missing a 2? That's right. And it ends up being D, yeah? Number 3. So you are going to need to know, although I've taught you how to do this on your calculator, Katie, you have to know the formulas as well, because I feel it's fair game for me to ask you to do some of it with the formula, or even ask, can you recognize it? 1000 P4, that's the same as NPR, which is N factorial all over N minus R factorial, which matches that one there. What's this one here? This is N choose R, 1000 choose 4. What's this one here? Well, it's the same as that one there, and they're both wrong. Number 4, how many different 3-letter arrangements of the word symbol are there? Well, all the letters are different, so I could go to fundamental counting principle and say I have 6, 5, 4, or I could go 6, P, 3. Either of those is fine. And 5 times 4 is 20 times 6, 120. Oh, is the answer none of these? It's 120, right? Number 6. How many 6-digit arrangements, permutations, can be made from that if the numbers cannot be used more than once? Okay. 6 digits. Any other restrictions? No. If there was, I'd do the other restrictions first. In this case, the only restriction is I can't start with a 0, so I have 5 choices. I've picked something that isn't a 0. Now the 0 is back in play. I got 5 choices, 4 choices, 3 choices, 2 choices, 1 choice. It's going to be 120 times 5. 600 B? It's going to be B. I should have figured that out. In Square City, the city's blocks form the shape of a 6x6 square. I think that means that you really have 6 rights and 6 downs if you draw it out. I did actually draw it out for my block A's. You end up with 12 factorial all over 6 factorial, 6 factorial. When I did that, by the way, 12 factorial, 6 factorial, 6 factorial is also 12 choose 6. It just happens to be that, so it's a shorter way to type it. You get 924 different pathways. How can I find out how many years this will take? And I think you get just a little bit more than 2.5 years, right? Number 7, in how many ways can 4 women and 3 men be seated on a bench if the men and women must alternate seats? You know, 7 benches, I think I'll draw a blank. I'll go to fundamental counting principle. There may be a shorter way to get there, but I'm going to go 1, 2, 3, 4, 5, 6, 7. Then I'm going to say to myself, oh, if it's 4 women and 3 men, what must I start with? 4, 3 choices, 2 choices, 1 choice, 3 choice for the guys, 2 choices for the guys, 1 choice for the guys. And now I see, oh, that's actually 4 factorial, 3 factorial, which is a little shorter way of doing it. 4 factorial is 24, 3 factorial is 6, 24 times 6. Is it D? Number 8. What's the 7th term of that there? I'll give you a question like this, but I think, Shannon, this one's actually a little too easy. On your test, I'll put something in front of that term or that term, because I'll give you a number to pull out of the exponent as well, okay? Anyways, if they want the 7th term, this looks like a job for tk plus 1 equals n choose k, a to the n minus k, b to the k. It's right on your formula sheet. I want term 7. What's n? N is your exponent, 8. If I want term 7, what do I want k to be, Holly? 6. Nice. A, strangely enough, Holly, is A. B, strangely enough, is B. But if it was something else like that, so it's going to be 8 choose 6. A to the n minus k, 2. B to the 6th. I said, well, that's wrong, that's wrong, that's wrong, that's... sorry, it might be none of these. Then I typed in 8 choose 6, and I said, ah, it is C. Open-ended. How many 4-digit odd numbers? Oh, they've given me a restriction. 1, 2, 3, 4. For this to be odd, I have 1, 2, 3, I got 4 choices. Now, in A, repetition is allowed. Katie, what that means is I'm putting the Scrabble tile back in the grab bag and shaking it up. So now that I started, I have 1, 2, 3, 4, 6 choices, 6 choices, and 6 choices, because I'm throwing it back in each time and there's no more restrictions. It's going to be 216 times 4, which is going to be 200 times 8, 16 times 4 is 864? What if I'm not allowed? Okay. I still have 4 choices for the odd digit. I picked an odd digit. Now I have 5 choices left. I picked another one. Now I have 4 choices, then 3 choices. It ends up being 20 times 12, 240? I like number 2, I like number 2, I like number 2. Number 2 is a nice question. Absolutely, on the written section of your test, I'm going to give you some kind of a factorial type of an equation to solve. Algebraically, solve that. Okay. Well, NCR is n factorial all over r factorial n minus r factorial. Fitting it into here, it's going to be n minus 2 factorial all over 2 factorial n minus 2 factorial equals 66. By the way, what is 2 factorial? On my next line, that's just going to become a 2. I haven't canceled out the exclamation mark. I've done the math. If this was a 3 factorial, what would it appear on my next line? 6. If it was a 4 factorial, it would be a 24. So I always worry kids are like, oh, you just canceled the factorial. No, I didn't. It's just a fluke. 2 factorial, it happens to work out 2. In fact, what I'm going to do is I'm going to move this guy over here. It's going to give me 132. And I'm going to rewrite this as n minus 2 all over n minus 4, because that's what n minus 2 really is. Factorial, factorial. Now what? Simplify. How? Can I just cancel out the exclamation marks? No! I have to expand and cancel. I have to expand by asking, hey, which one's bigger? N minus 2 is. This is going to become n minus 2, n minus 3, n minus 4. Ooh, 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 stop there. Why? Because that's what I have on the bottom. I get n squared minus 5n plus 6 equals 132. What kind of an equation is this? It's a quadratic. How do I know? It's got a squared. How do I solve a quadratic? I don't factor yet. What do I have to do first? Got to make it equal to 0. I get n squared minus 5n minus 126 equals 0. I have no idea what goes into 126, so I started guessing. I thought, well, maybe 12. Nah. Maybe 13. Nah. Maybe 14. Ah! Oh, and how far apart are 14 and 9? 5 apart. I can make this work. I can make this work. I think it's going to be n minus 14, n plus 9 equals 0. My roots are 14 and negative 9. Oh, extraneous. So if you got that, you get 3 out of 3. Otherwise, here's how I gave out the part marks. Come on. Give you 1 mark if I saw this statement here. 1 mark if I saw the quadratic. 1 mark for the answer. If you didn't cancel out the extraneous, half mark off. Pathways. Is this a regular pathway question? No, then I can't use my shortcut of factorials. I'm going to have to Pascal's triangle this. You'll get the same answer, by the way, if you go this way to that way or this way to that way. I had one of my kids in my other block do it that way. I think it's easier to go this way. I'm going to go this way. First, I'm going to zoom in. And then, because these are so much fun, let's do this together. Ready, Shannon? How many? Nice. I always go out. Don't Phil. Always discipline yourself. 1 here, here, here. Yep. Yo. Yeah. Sicher. Yeah. Uh-huh. Sure. Yo. Da. Yo. Yep. Yo. Yep. What flows into there? What flows into there? It's meant to be really easy, even though it's a tricky question. What flows into there? It's screaming out at you. Nothing. What number goes there? What it's really saying is, you can't, if you're always moving closer, you can't ever get there, because to get there you'd have to move further away or backtrack. You see what I mean by, like, now you see, oh yeah, nothing's 0. Keep going. Yes. 11, 5, 9, 15. Yes. 16, 14, 24, yeah. 30, 38, 68. Okay. If you got that, you get 3 out of 3. If you used Pascal's but you made a math mistake, you get 2 out of 3. If you left it blank, you get 0 out of 3. Most common is dumb math mistakes. I did one last block with my students when I was doing this. I went, what did I do? 9 and 6, I put a 14 there. That's almost fun, Mr. Dueck. Yeah. So do one of those on the written section of your test. Number 4, this will be on your test, but it'll be multiple choice. What is the 17th term of the 23rd row? 22, choose 16. 74613. Anybody draw it out? So 23 rows is enough to dissuade you from drawing out past? Yes! Excellent. You know what? This is going to be multiple choice. I'll even tell you what the answers will be. I'll bet you one of the answers will be 23, choose 17. One of the answers will be 22, choose 17. One of the answers will be 23, choose 16. And one of the answers will be the right one. That would make sense because those are the most common mistakes. I like number 5. At least 3 girls. You know what? There's 2 subcategories. This is a job for a bucket. Girls, boys, 10, 8. At least 3 girls means 3 or 4 or 5. Oh, and stop because it's only 5 people that we're picking. Let's see. From 10 girls, choose 3. I guess that means from 8 boys, choose 2. Or from 10 girls, choose 4. I guess that means from 8 boys, choose 1. Or from 10 girls, choose 5. And from 8 boys, choose none. And when you're done, I got 5,292. In terms of part marks, I'll probably give you a half mark for that, half mark for that, half mark for that, half mark for the answer, but if you got the right answer, I'm good. Okay. Number 6, find and simplify the term containing x to the 14th in that. Ugh. First, I have to figure out when it occurs. Roxanne, what's my great big exponent on number 6? What's n? Too slow. Meant to be very easy. What's my great big exponent in number 6? What's n? Too slow. Ready? Roxanne, look up. What's n? 11. Okay, ready? Scene 1, act 1, take 2. What's my great big exponent in number 6? What's n? 11. So, Roxanne, I'm going to ignore the chooses. It would be 11, choose 0, 11, choose 1, 11. I'm going to ignore that. I know it's going to be this, Roxanne. A to the 11th, a to the 10th b, a to the 9th b squared. Yes? Let's see if I can figure out the pattern from that and figure out when the x to the 14th appears. This would be a 2 to the 11th with no x's. This would be a 2 to the 10th and x squared to the 1. This would be a 2 to the 9th, x squared, squared. How many x's in the first term? How many x's in the second term? How many x's in the third term? What's the pattern, Amanda? Pencils down, fists up. So the first term is going to have none, then 2, then when will the x to the 14th appear, Katie? Term number what? 8. I want term 8. Oh, and I'm going to use the term k plus 1 equals n choose k a to the n minus k b to the k shtick. Roxanne, what's m? Careful, Roxanne. If I want to get an 8 right there, what does k have to be? Don't say 8. If I want to get an 8 right there, what does k have to be? 7. Roxanne, what's a in this question? Yep. What's b in this question, my child? Can't hear you, sorry. What's b? With authority. X squared. That's the second term. Yep. So it's going to look like this. N 11 choose k 7 a 2 to the n minus k to the 4th. I can do that in my head. b x squared to the k 7th. I think numerically it's going to be 11, 11, choose 7, and then times, can you see a 2 to the 4th here, Roxanne, as well? Are there any coefficients in here that are going to pop out of the 7th? Nope. So the coefficient is going to be 5280 x to the 14th. That's the term that has an x to the 14th in it. In terms of part marks, I did something like this. 1 mark if I saw that, 1 mark for the answer. Number 7. What is the coefficient of the constant term, i.e. rag g, the term independent of x? Well, to figure out the coefficient, I need to know when that term occurs. How am I going to do that? Don't ask me. How am I going to do that? Holly, what's n in this question? 8. So here's what that means. It's going to be a to the 8th, a to the 7th b, a to the 6th b squared. I can usually figure it out after 3. I know it would also be 8 choose 0, 8 choose 1. I don't care about that yet. I'll come back to that. What's sitting where the a is, Holly? So it's really going to be x to the 8th, x to the 7th, x to the 6th. What's sitting where the b is? And right now, I don't care about the 2. I just want to see what's happening with the x's, because that's going to tell me when the x's cancel. So I'm going to go 1 over x. Oh, no, not there at all, Mr. Dueck. I'm going to go 1 over x all squared. Let's see if I can spot the pattern. How many x's are there in the first term, Itzel? Grand total. 8. How many here? 7 on top, 1 on the bottom. 6. How many here? 6 on top, 2 on the bottom. What's the pattern? What are the x's going down by? Hands out, fingers out. The first term has an x to the 8th, then an x to the 4, 2. What term is the constant term? What term has 0 x's? What term do the x's all cancel? What is the independent term of x? Da-da! Oh, let's make our list here. Holly, you said n was 8. Holly, what's k? If I want a term 5 here, what does k have to be? Careful. Yes. A is x, b is 2 over x, so it's going to be 8 choose 4, x to the 4th, 2 over x to the 4th. Steph, are we right? How many x's on top here? How many will end up on the bottom? How many left? Hey, we are right. In fact, I think it's going to be 8 choose 4 times 2 to the 4th. Yes? 8 choose 4 times 2 to the 4th. 1120? And I gave up part marks like that. If you figured out it was the 5th term that got you a half mark, if I saw that, half mark, and half mark for the answer. Turn the page. I like number 8, I like number 8, I like number 8. There's going to be a question like number 8 on your test, where I just ask you to write out the first 4 terms. Hey Sabrina, what's n? So what that means is it's going to be 9 choose 0, 9 choose 1, 9 choose 2, 9 choose 3. I could keep going, but they only want the first 4 terms. What did you say n was, Sabrina? So it's going to be a to the 9th, a to the 8th, a to the 7th, a to the 6th. Yes? No b's. 1, 2, 3. Now let's carefully substitute stuff in. 9 choose 0 is 1. A to the 9th is 2x to the 9th. Plus 9 choose 1 is 9. 2x to the 8th, negative 3y, because b is negative 3y to the 1. And this term, I think, is going to become negative later on. Plus, what's 9 choose 2? Oh, okay. 36. 2x to the 7th, negative 3y squared. Plus 9 choose 3, 84. 2x to the 6th, negative 3y to the cubed. Okay. Then I carefully multiplied this out. I got 1 times 2 to the 9th, and the x to the 9th dropped down. I got 9 times 2 to the 8th times negative 3 to the 1, and then the x. You know what? I got this. 512 x to the 9th minus 6,912 x to the 8th y plus 41,472 x to the 7th y squared minus 145,152 x to the 6th y cubed. How many terms are there that I asked for, Carson? How many marks is this worth? What would be a smart marking scheme? Letting each one be worth how many marks? A half. Number 9, I change this name every year, so when I first typed this out, it was a student named Allie. This year it was Itzel, our disc jockey. She has chosen to play 10 songs for the school dance. Itzel creates one 10-song compact CD. How many ways can she arrange the songs? Three, 6, 2, 8, 800. 3,628,800 ways. Ah, but Itzel's done music before. She's got game. She understands that the first 3 songs are important. They set the tone for the evening, and she has chosen Math is Wonderful, the never-ending algebra problem, and You plus Me equals Us. Oh! How many ways can those 3 songs, all it's interested in those 3 songs? 3, then 2, then 1. Now, those 3 songs have to be at the front of the disc. And there is ways to mix them up. How many songs are left on the disc? 7. Because 10 take away 3, Itzel is what? 7. How many ways are there to mix up those 7 songs? That many ways. What do you get? 30,240. Now, here's how this score works. For some strange reason, multiple choices are 1.5 each. And then the written, I told you what each one is worth as we did it. Now, I think actually, you may notice on my original here, this quiz is actually out of 35. I made it out of 33. It's possible to get more than 33 out of 35 if you got perfect. Hey, you can get some bonus marks. Add up your score, write it here at the top. However, I don't want you to hand the quiz in. I want you to have it to study from, so we'll do our usual trick of the person at the end of each row tearing out a piece of paper, writing their name and their score on it, and then passing. Questions from the homework, 10B. Okay. One term in this expansion, I like this question, there's going to be one like this on your test, is that determine the value of it. All right. First, I need to figure out what term this is, what term number. Term 1, term 2, term 5, well, could be up to term 12 because the exponent is an 11. Then I'll try and work my way backwards. What's the exponent on the x? What's the exponent here? So it would start out, the first term would have an x to the 11th, yes? Then an x to the 10th, then an x to the, what term number is this? This is the fourth term. Okay? What's n in this question? What's k if I want the fourth term? What's k if I want the fourth term? What's a? What's b, strangely? B. So if we're using this tk plus 1 equation, it would end up being 11, choose 3, and choose k. A to the n minus k. B to the k. So far, so good? Yeah? And I was going to write, don't write this down, I was going to write term 4, but then I went, no, wait. I actually know what term 4 is. It's negative 4, 5, x to the 8th. See, we put all that together? That's a lot of putting things together to get this first line. Once I get there, though, it's not too bad, because the x to the 8ths cancel. What does 11 choose 3? Anyone, don't all rush for your calculators at once. What does 11 choose 3? 165? This is the real equation that we at now. Negative 4,455 equals 165b cubed. Now what? Divide by 165, and then how would I get rid of a cubed? It's going to be negative 4455 divided by 165. Where's cube root? I think if you hit math, there's cube root, option number 4 of my previous answer. B is negative 3. Any others? Yeah. 8b. Okay. What's my exponent? How many terms are there going to be? 5. It's going to be 4 choose 0, 4. Here we go. I have a feeling I might need lots of room, so I'm going to start right here. 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. A to the 4th cubed. Whoop, why did I come up with a B all of a sudden? Squared. By itself, none. No B's. 1 B, 2 B's, 3 B's, 4 B's. That part you have to have memorized. That pattern you have to have memorized. Now let's carefully substitute. I know 4 choose 0 is 1, x to the 4th, plus 4 choose 1 is 4, x to the 3rd, negative 1 over x to the 1. Plus 4 choose 2 is, I have no idea. What is 4 choose 2? 6? X squared negative 1 over x squared. Plus 4 choose 3 is the same as 4 choose 1, which was 4. X negative 1 over x cubed plus 1 negative 1 over x to the 4th. You okay with that so far, Amanda? Yeah? Can you hand it in the proper blocks here? Thanks. First term, yes? Second term looks like it's going to be a negative 1 to the 1 times a 4 in the front, it's going to be a minus 4. How many x's on top? How many on the bottom? 2 left on top. The third term, I have a 6 times a negative 1 squared. What's a negative 1 squared? Times a 6. It's going to be a plus 6. How many x's on top? How many on the bottom? Oh, there's the constant term, which they could have asked as a different question, but there's the constant term. Here, I think it's going to be, can you see, Amanda, 4 times negative 1? It's going to be a minus 4, 1x on top, 3 on the bottom. In fact, I should really write it as minus 4 over x squared. And the last term is going to be plus 1 over x to the 4th. That should be it. That is it. 5 terms, 1, 2, 3, 4, 5. Yep. Noticeable pattern in the exponents. Yep. That's also another way to double check, by the way. Your exponents should form some kind of a pattern. If suddenly they're going down by 3s and all of a sudden one of yours goes up by a 5, you've goofed on that one. Any others? So, because we are pressed for time, I'm sorry, we're starting next lesson, next unit. Fairly easy one, though. So, starting the next unit, lesson 1. This is mostly terminology and some basics. All of us have a fairly good, very basic understanding of the odds of something occurring. But Ryan, we're very bad at anything even remotely complicated. It's why we're so superstitious. It's why we buy lottery tickets. It's why Las Vegas works. We're lousy at figuring out probabilities in our heads unless they're really basic. But because we're so good at the really basic ones, we have an overinflated confidence for anything that's not really, really, really basic. Example 1 says, visualize rolling a die. By the way, 2 dice, 1 die. If you're doing the proper English, I will probably say 1 dice, but I will never type that, or almost never type that, because I can't type bad grammar. My English somewhere has to be more gooder. What's the theoretical probability of getting a 5 when you roll a die? This one you all know. Nicole. Okay. Now, don't write this down. I would like to write this. The probability of getting a 5 is 1 out of 6. That's way too much writing. So one of the things, Katie, I want to show you today is the notation. Here's how we write this. We use a capital letter P for probability of getting a 5. We use a bracket. We put the event that we want in the bracket, and I would read that as the probability of getting a 5 is 1 over 6. That's way shorter than writing out that previous sentence. So if I roll the dice 6 times, how many times should I get a 5? In theory, once. Am I guaranteed to get a... No. That's the difference between theoretical probability and experimental probability. Theoretical probability says, well, now if I rolled the dice 12 times, in theory I should get 2 5s. Will I? Probably not. Now, if I roll the dice 6 million times, in theory I should get 1 million 5s. Will I? I'll get much closer. Experimental probability says this. The more times you perform the experiment, the closer your experimental results will match the theoretical results. What probability says is, look, the longer you play this game, the more your actual event will start to match the theoretical event. But it has no power. Nothing prevents me from rolling 5 1s in a row. It's statistically unlikely, but it's certainly not impossible. Okay? The first rule we have in probability is very simple. It says this: if we can count it, we can solve it. So here's a deck of cards. Suppose one card is drawn from a deck of 52 cards. What's the probability that it's a face card? Well, here are my face cards. Count them. How many are there? Thank you. I hope you used the fundamental counting principle, went 3 times 4. Yeah, okay. I would write this. The probability of getting a face card is 12 out of what? 52. By the way, that fraction reduces. Don't bother. I'm going to tell you, Roxanne, do not reduce your fractions. The reason is often you'll want to leave it with the common denominator so you can do other math as well. In your final answer, you don't need to reduce either. You can, you don't need to. However, if it's multiple choice, and part of your test will be multiple choice, I will reduce those fractions. And so I want to show you, because I'm lazy, a good trick. If I haven't showed you this already, all of you on your calculators, go 12 divided by 52 and press enter. That's the decimal. If I press, Katie, math, enter, because it's the first option in both submenus, that's the fraction in lowest terms. I can reduce fractions by myself, except, do you remember when we did the 5-card poker hand last unit? There was 2.6 million combinations. If we're looking at poker odds, you're going to have a 2,600,000 something underneath there. It's going to be yucky to reduce them. I'm going to say to you, don't bother. Type the top in, type the bottom in, press math, enter. Okay? A red ace. That's yoink. Ryan, how many out of? So the basic rule of probability, if you can count it, you can solve it. The problem is most of the interesting questions have far more outcomes than we can count. That's why we did combinatorics. You always do combinatorics before you do a probability unit. You have to learn to count without actually counting. Here's our formal definition. If an experiment has n equally likely outcomes, of which our outcomes are favorable, our success, our red aces, our wins to event A, and the probability of event A occurring is the number of successes divided by the number of outcomes. Now that's really obvious, except I'm going to tell you right now how I can give you a very basic question, and just this very basic question, Amanda, none of you will intuitively guess the right answer. Here's the basic question. What's the probability that a family of 3 kids, exactly 2 are girls? What are the odds? I'd like you, off in the margin, to try and write down what you think the answer is. What out of what? Do a best guess. And you're going to find out we're terrible. But try it anyways. I always do this, and I'm curious, someone can impress me if they actually guess right or know how to do this. And this also lets me introduce to you the most useful tool in this unit. It's called a tree diagram, a tree. What a tree diagram does is it gives you a systematic way to organize all of the possible outcomes. How many kids are there in this question? 3. My tree is going to have 3 levels. It's going to look like this. The first kid could be a boy. The first kid could be a girl. Second kid could be a boy. Second kid could be a girl. Second kid could be a boy. Second kid could be a girl. Third kid could be a boy, girl, boy, girl, boy, girl, boy, girl. By the way, how many outcomes are there grand total? How many branches are there at the bottom? How many? It's going to be out of 8, which already surprises people because I'm willing to bet most of you didn't think when you looked at 3 kids, 2 girls, and 50-50 boy, girl. 8! 8 does not pop out of any of those numbers very easily. And then you can either circle or put a check mark or highlight the paths that match what we're talking about. Which paths have exactly 2 girls? That one. Or if you don't want to circle it, you can go that one. That one. That one. Yeah? 3 out of 8. Anybody guess 3 out of 8? This is why Las Vegas makes their money. People have terrible estimation of this is why we're also superstitious, because we're always trying to look for patterns that aren't there. This is why we buy lottery tickets. Even I'm susceptible. I bought my first lottery ticket about a week ago. I was in the store with no cash and I was buying a pop, and I felt so stupid using my debit card for $1.29 that I said, throw a quick pick on there so at least I could somehow feel like I was using my debit card for $3. Dumb reason to buy, but not much dumber than the actual reasons to buy. Okay. Example 4, the pointer is spun twice. Here's our pointer. How many possible outcomes are there? 4, and they're all equally likely. Eventually, we'll start to deal with it. Ashley, what if they're not all equally likely? What if one of those wedges was bigger than the other ones? We'll deal with that later, but for now, they're all equally likely. Okay. Tree, I guess. Wide tree, because it's going to go like this. 0, 5, 10, 20, 0, 5, 10, 20, 0, 5, 10, 20, 0, 5, 10, 20, 0, 5, 10, 20. We're spinning twice. Find the probability that you win a total of $10. Okay. Oh, how many outcomes are there? How many outcomes do you win exactly $10, no more, no less? Here, here, here. That's it. 3 out of 16. B. Probability of same number. Doubles, I think we call that when we're playing a game, right? It's probability of the same number. Oh. How many? See it? I think there's 1 on each major branch, right? 0, 0, 5, 5, 10, 10, 20, 20. Which again, I know is 1/4. Who cares? I'm not going to reduce. Example 5. 2 bills are randomly selected from the pot without replacement. Find the probability that you win a total of $10, no more, no less. Okay. I guess my first branch I'm going to have 1, 2, 3, 4 possibilities. 0, 5, 10, 20. But then, Katie, if I walk down this branch, I think there's only 3 possibilities. I've already picked the 0. Down this branch, still left is a 5, a 10, or a 20. Yes? Down this branch, still left is a 0, a 10, or a 20. Down this branch is a 0, a 5, or a 20. And down this branch is a 0, a 5, or a 10. You see why I only have 3 options at the end of each branch now? Because we're not replacing. In fact, how many possible outcomes are there here, Cassandra? 12. How many do I win $10 exactly? There, there. Is that it? Okay. A more interesting question would be, on average, how much money will I win? This is what Las Vegas would want to find out. We call that the expected winnings. We unfortunately don't look at it in Math 12. We should. It's one of the key ideas. If on average, Sabrina, you stand to win, for example, $12, then if I want to make money in Vegas, I charge $13 to play. On average, I'll be making $1 profit every time. Enough people will win to keep people happy. Someone will win several in a row and make a profit, but most people will lose money and I'll make a profit. It says homework in the workbook. Your homework is actually not that. Your homework is to study, to work on the combinatorics review, this thing, which is due on Wednesday. Now, I just found out that I didn't photocopy an answer key for you guys. I'm a little grumpy. I thought I'd attach the answer key to this. I'm going to photocopy that for you guys right now and get it to you. You have the remainder of class to work on the combinatorics review.